Yeah, we are good to go. Start.
A very good afternoon to all the participants. We are on the day 2 of the webinar, and yesterday we had 3 speakers, and today also we are going to have 3 speakers. So the first speaker for today is Mrs. Jenny Sharwood from Australia. I'll just give a brief about her. After graduating with first class honors in chemistry at the University of Melbourne, she taught chemistry, science, and mathematics in a range of schools for a career spanning over 26 years, fulfilling several leadership roles over that time. She left teaching at the end of 2001 to focus on a professional writing career, which began in 1989. Since 2000, she has been commissioned by the Victorian Curriculum and Assessment Authority to undertake a number of advisory and writing roles. These have included serving on exam writing panels, researching and writing a benchmarking report on assessment of chemistry across Australia, England, and France. Jenny was the lead author and a series editor of the number of chemistry and science textbooks, teacher guides, and many other resources, as well as conducted many teacher workshops in these subjects. It's a pleasure to welcome her here. Some of her texts and their accompanying teacher resources have won the Australian Award for Excellence in Educational Publishing in their category, as well as winning the overall award. The science books have now been adapted for other states as well as international schools. In her texts, there is a great emphasis on the relevance of science and particularly chemistry to industry, to everyday living and the environment, with many case studies and stories to help science or chemistry more alive to the students. Jenny has been a member of the Australian Society of Authors for over 20 years now. She was appointed as the writer for a 3-year curriculum project on climate change, renewable energy, and sustainability by the Australian Academy of Technology, Sciences and Engineering. In addition, she is very active in the Royal Australian Chemical Institute, RACI, and that is from where we know her personally. So she is the chair of the Victorian Chemical Education Committee and has been the lead writer for the Year 11 and Year 12 question papers for the RACI MCQ quiz for past several years. And the most important thing is that she was awarded the Medal of the Order of Australia for her services to the secondary education in June 2017. In June 2019, in the year 2019, the Chemistry Education Association named Jenny as the Chemistry Educator of the Year in the recognition of her dedication and services to chemistry education for over 50 years now. It's a privilege to welcome her here, and now I pass on I invite Jenny to start with her presentation. Please enjoy. Thank you.
Thank you very much. It is a great honour to be presenting to you today, and I would like to give you greetings from the Royal Australian Chemical Institute and also the committee that is involved in producing the Australian National Chemistry Quiz, as well as the Chemical Education Committee of Victoria. I'm going to now put this onto a PowerPoint presentation for you so that you can see what I am saying as well. So I'll just put it over there for you, and it won't be a minute, it'll just come up. Oh, that's not coming up right now. We'll just try it again. I'm not quite sure why it's not coming up. I won't be a moment. The host has disabled the participant screen sharing, but I should still be able to share my screen, shouldn't I? So I'll just try it again. It won't come up. Is there a problem on your side? Because it keeps on saying you have disabled the participant screen
just try it
sharing.
again, once again.
Are you able to solve that problem? Because it won't, my PowerPoint is not coming up.
Ma'am, just click on share screen right at the middle of the screen, right bottom.
Click on, sorry, the
Share screen, which is there would be a green icon on the middle bottom.
on the share screen. All right. Well, I have clicked on that about, here we go. All right. Here we are, and
Yes.
it won't be a minute, and I'll put it on there. Sorry about this. For some reason, it's not. Here it is. All right. I'm sorry about that delay, but I hope you will find the rest goes smoothly. So, first of all, writing suitable questions for a multiple choice first depends on the purpose of the test. Multiple choice tests can be used as an introduction to a topic, to see what the students already know, a quick quiz at the start of a lesson to challenge and test student understanding and ensure a disciplined, focused start to the lesson. Part of the assessment of mastery of a particular topic or a particular set of skills, either for the teacher or for the student for self-assessment. It can be part of a final examination or an entry examination or a competition such as MCQ. I have actually used that in all of those ways. But whatever the purpose is, all multiple choice questions should be fair and accurate, be written in accessible language, using as few words as possible, including in the alternative answers. They should use international conventions for terms, symbols, and units. They should be well laid out, using tables, annotated diagrams, flowcharts, and other devices when these can help the students more easily obtain the information. They must only have one correct answer. They should not take students any longer than 90 seconds to answer, and they should not require the answer to another question in order to be solved. Now, when I talk about using as few words as possible, I must admit for the MCQ, sometimes we have to add a little more because we are catering for so many different curricula. You know, when you're testing your own curriculum, you already know what the students should know, but we don't know, and our MCQ is used in over 20 countries. So we have to assume some knowledge, but sometimes we teach a little before we ask a question. We feel that's the only thing we can do, to be fair. But also, where possible, the questions should be fascinating, meaningful, with up-to-date information, so they inspire an interest in chemistry. And where possible, accompanied by an illustration or diagram to assist the visual learner, or a photograph to stimulate interest. Now, what kind of things are we testing? Normally in chemistry, we're testing thinking skills and chemistry skills or science skills. So we need to plan the test very, very carefully so we can test a variety of these skills. Now, there's the lower level skills such as recall and understanding. There's middle range skills skills, which are application. Now, they can be numerical problems, they can be processing data, it could be tables of numbers or graphs, it could be applications of principles such as how you systematically name organic chemicals. They're just, but then there's the higher level skills, analysis, and the kind of analysis ones you can ask in multiple choice could be drawing conclusions from results, identifying patterns in data, identifying from experimental results possible sources of error and uncertainty, identifying and explaining the effect of changing experimental conditions on the results. In fact, I'm going to show you an example of a question of what I mean by that. Evaluation, that can include assessing the validity of conclusions based on the evidence or assessing an experimental design. Synthesis can include designing a modification of an experimental procedure that will improve its validity. So tests should be balanced with respect to the range of skills tested, the range of curriculum areas being tested, and the level of difficulty of the questions. Most multiple choice questions will be based around the lower and the middle range of skills. The higher level skills are usually tested in short and long answer questions, but you can still design multiple choice questions to test these skills. The test should progress from the least difficult to the most difficult questions. This allows the students to build up confidence and can help them achieve greater success. So let's take a lower level skill, understanding. Guidelines are: the language must use international terms and conventions. It must be as precise as possible. The distractors should reflect common misconceptions and misunderstandings the students have. The alternative answers should be of equal length or in order of slightly increasing or decreasing length, because it's very rare to be able to get them exactly the same. I'll give you an example. Now, this was a question that is an example that isn't quite perfect yet. So it says ammonia gas is used as a fertilizer in the purification of water and the manufacture of many chemicals such as dyes and nitric acid. It has a pungent odour and is toxic. When it is bubbled through water, it completely dissolves in the water, forming a weakly basic solution. Why is ammonia gas so soluble in water? And there you'll see there's 4 alternatives. 1, it's a light gas. Well, that's true. It is a weak base. That's true. It forms covalent bonds with water molecules. Well, that's definitely not true. And then there's this great long answer at the end. Ammonia molecules and water molecules are highly polar and are attracted to each other by dispersion forces, dipole-dipole attraction, and hydrogen bonding. I think you can see some of the problems with it. There's too much in the start, but at least the question is separate from the information, which is important. But you look at that very last alternative. A lot of experimentation and research on multiple choice questions by university people have found that it doesn't matter what alternatives say, if one is so much longer than the other like that, the students will automatically select it. So this needs to have a lot of change. Also, although the first 2 statements were true, they have to be changed so they're not true. They might start off as something true, but they have to end as something not true. Otherwise, you will only have 1 correct alternative answer. So it needs to have them all, the answer's made of this almost the same length. There needs to be less facts in the introduction, but still keep some because that makes it interesting. And we need to reduce alternative D to the very key reason for ammonia's high solubility. And I think it needs to provide the chemical formula of ammonia to help those students who can think through the answer, but if they know its composition. So here's a suggested rewrite. You see, just one sentence about the uses of ammonia, which also shows its formula. And then, unfortunately, for some reason, and this is just a mistake of mine, the ammonia molecules are more highly soluble in water, should be on the next line. I'm not quite sure how that happened. But notice I've said, you can see the alternatives just slightly increase in length all the time. The first one is the one that's not true. The second one now says, react with water molecules as do all basic substances. Well, all basic substances do not react with water. Hopefully the students will have that general knowledge. Take, for example, iron ore is basic, but it doesn't dissolve in water. They are very light. Well, that's true, but then it says, and all light gases dissolve completely in water. Now that makes it not true, because you think of oxygen, which is a light gas. If oxygen completely dissolves in water, we wouldn't have any oxygen left in the air. It would all have dissolved in the ocean. And now the key part for the correct answer is it homes in on hydrogen bonding, which is really why ammonia is so highly soluble. For quantitative questions, the guidelines are, these questions should require only 2 or 3 steps. No more, because it's expecting too much in 90 seconds. The distractors, the wrong answers, should be calculated by predicting typical errors the students will make for that calculation. So you have to choose a question in which students could make at least 3 errors. The number of significant figures should be consistent in the question and the answers, and they should be appropriate. The answers should be listed in ascending or descending order, not in random. And the units should be internationally accepted units. Now here's an example of a faulty question. It says a teaspoon of sugar, and it gives its formula, is put into an Olympic-sized swimming pool. The mass of the sugar is 4.20 grams and the volume is 2,500 cubic meters. After thoroughly mixing, the number of molecules in each centimetre cube of water will be. Now, I think you can probably see some of the problems with this. The idea of putting sugar into a pool of water could interest the students. It's better than just having a normal dilution problem. So it's good from that point of view, but it doesn't actually say which sugar it is. And because there's many sugars, I think it should. And then the next thing is, it is absolutely not clear. The question itself, it says, after thoroughly mixing, the number of molecules in each centimetre cubed of water is. Now that doesn't tell you, are you supposed to calculate how many sugar molecules are in the 1 centimetre cubed, or how many molecules altogether are in there? That's a fault with the question, and it would leave students in trouble. As well, if you try the calculations, there's too many steps needed. And the wording, as I've said, needs to be more precise. I have actually gone through the calculations. I won't go through them, except say there's 4 steps. They've got to calculate the molar mass of sugar. They have to calculate how many molecules that means. They have to work out the pool volume to the centimetre cubed, and then they have to calculate how many molecules are in 1 centimetre cubed. That is too many calculations for a student for 90 seconds. So my advice is that you give them the molar mass of the sugar instead of expecting them to do that, because that skill is not related to the question. But because of the other 3 steps, there are a lot of errors students can make, and so that will allow you to have a good question. So, as I've said, it needs to have the molar mass provided. You need to have the language tightened. The sugar should be identified. And in the case of the previous edition, one of the distractors required 2 different errors to be made. So I think it's better to just have 1 error per distractor. So here's a suggested rewrite. A teaspoon of sucrose, table sugar, is dropped into an Olympic-sized swimming pool. After a while, the sucrose molecules are spread evenly through the water. I think that describes it better. Then it gives the data, and notice now I have added the molar mass, and then it gives the new alternatives. I think that is a better version of the question than the original. It's much tighter, I think. Now, when it comes to more higher level skills, and that's the last example I will do, I really recommend that somewhere, if you are testing an entire curriculum, and certainly this is what we do in ANCQ, I think at least 2 questions, at the very least, should be about experiments, experimental results and experimental procedures, because experiments are such an important part of chemistry skills. So now here's a question, and it's about the analysis of some diluted vinegar solution. And that it describes what happens about the students, first of all, analysing some sodium hydroxide by titrating it against previously standardised hydrochloric acid. And the titrations are repeated until it's obtained. There's the equation that's provided in this question that is not good enough, that needs improving. And then it goes through what happens next. So you can see there's an awful lot of reading. And now look at the results. The results are just like an essay. They're not in a table. And then it asks what was the concentration of the vinegar. So I think there's a lot of faults in that question. It's hard for students to visualise just from words what happens in the experiment. Students should be trained in their experiments to put their results in tables. But worse than that, there are far too many steps to find the answer to this question. Far too many steps. So it has to be simplified. The other thing is there's another follow-up question, which is in the analysis or evaluation sort of area of questions. This is much harder. So a question like that, we would make the last one on our ANCQ test. Which of the following would have given a lower result in the final answer? Rinsing the reaction flasks, using HCl in the first titration that actually wasn't the concentration it said, using just the last burette reading in the second set of titrations, rinsing the reaction flask with the vinegar. Now, all of that will require a lot of thinking about what effect each one of those will have on the answer. So that is a much more challenging question. But really, there's a real problem with all of those. As I said, there's far too many words. A flowchart will help. The results should be in tables. There's too many results. You may have noticed the burette and pipette volumes were not all given to the same number of decimal places. The International Convention for volumes is centimetres cubed, not millilitres, though I must admit in Victoria, we use millilitres. That was just a decision out of my control. The International Convention for writing chemical equations is to show states, and the students may not know how to identify concordant results. So there's some problems with it. So here's the start. I mean, unfortunately, it still takes a bit of writing, and that is why, but because the writing is related to 2 questions, and in fact, you could even make 3 related questions, although none of the answers can depend on the other ones, it is justified to have a fair bit of information. So I've just said what the task was, and I've said the correct name of the ethanoic acid given its formula and so on. I've told what the students were given, but then I've done a plan. Now, I must confess, I have borrowed this plan because I've only had a short time to prepare for this webinar. I borrowed this plan, which I designed from our titration competition that we hold in Australia. I don't know whether you've heard of that, but in Victoria, the titration competition, which usually, I mean, not in this year with the virus, but in other years, we have over 400 teams enter the competition, and they do have to analyse vinegar. But we give them this chart so they can picture what the plan is. And you can see, they can see there's 2 sets of titrations. They can see what is in the burette and the pipette, and so on. So that helps them picture what they're doing in a much simpler way than an essay. Okay, it then says they repeated each set of titrations until 3 concordant results were obtained. Then I've said what that means. Only the results that were within 0.05 centimetres cubed of each other were used to calculate the mean volume. Then I've given the equations for the 2 sets of titrations. These are now in the International Convention for Equation Writing. So they've got the states, and you notice how the states are shown. Some people put them below the line. That is not correct. And now the students' results have been put in a table. As well, there's not so many results, you will see. You can see that I've given them the results of the first set of titration because it's not fair to ask them to do that as well as the second. So now they know the concentration of the sodium hydroxide. They know the volume of the vinegar solution actually used in each set of the second set of titrations, and they can see 4 values. And if you have a look at it, the first one shows they've clearly overshot the end point, but the other 3 are within 0.05 centimetres cubed of each other. So now it's a much more doable question for the students. And notice too, I put the students' results in question 29 because they're not needed to answer the next question, really. Though you could look at them to help. But that's to make it a bit more streamlined. And then question 30 can be done. It takes a bit of thinking, but I think the students can do it. I'm not sure if I have time to go through that for you, but there are other questions you could also ask instead of the one I wrote, or as well as some other questions you could ask is, which of the following 4 pH curves, which obviously would be drawn, represents the second set of titrations? So you could put it like that. Why must sodium hydroxide solution be standardized just before it's used in an analysis? And that's looking at them to realize it's not a primary standard because it absorbs carbon dioxide out of the air. So if that's in your curriculum, you know, they can use that. So there's other ways you can do that. So some final advice. This is what we do when we write MCQ and what I've always done in writing my books. In fact, I've travelled all over Australia meeting chemists, chemistry researchers and so on to get stories and interesting facts for students. So my advice is research chemistry articles to find intriguing chemicals and chemical processes to be used in the test to make the students, help fascinate the students. And often you can get great photos and things from your sources as well. And this is really important, after about a week, sit for your proposed test to see how long it takes you. Why I say a week is it's too fresh in your mind if you sit for it immediately. I mean, you can sit for it immediately as well, but you need to sit for it again a week later and see how long it takes you, because if it takes you more than a third of the time you've given the students, it's too much, because you should be able to do it much more quickly than them. You also need to ensure you've got all the necessary data to wherever it's appropriate in your test, such as atomic masses they might have to use. And then, and this is really important, and this is very much what we do with AMCQ, you need to ask at least one other teacher and an expert, preferably a tertiary chemistry expert, to review the test. Particularly, we do this for the competition, but also if, for example, it's a final exam, an entry exam, where the student results are very important, you need an expert to review the test to make sure all the chemical facts and the language and calculations are correct, and that each question definitely only has one answer. So with that, I'll finish, and thank you so much for that. I'll just bring it back to myself, which is there. And it's been a real pleasure. If you would like a hard copy of my presentation or the PowerPoint on its own, I can easily send them to you. I'd be happy to. If you would like to see any of the experiments that we give for professional development, our Chemical Education Committee, I can help you with those as well. So in any way I can also help you, I'd be delighted to do so. So thank you very much.
Thank you. Kaustubh,